Hi viewers, welcome to Learning Electrical Engineering channel. In this video we will see about superposition theorem and the problem solving using the superposition theorem. First we need to know the definition of superposition theorem. The definition is the superposition theorem states that the voltage across or current through an element in linear circuit is the algebraic sum of the voltage across or the current through the elements due to each independent source acting alone. That means a circuit may have n number of independent sources. To find out the circuit variables, that is voltage or current, we need to calculate the effects of individual independent sources. Then finally we need to do the algebraic sum will provide the value. For example, in this circuit we have one current source and one voltage source. In this, to find out the value of current through the 5 ohm resistor, we need to turn it off the voltage source first, and we need to find out the flow of current through 5 ohm with the current source 4 amps. Then we need to turn it off the current source. Then we need to activate the second source, that is voltage source. Then we need to find out the value of current flowing through the 5 ohm resistor, and then finally we need to do the algebraic sum will provide the combined effect of the all independent sources, and it will provide the combined effect current value which is flowing through the 5 ohm resistor. Now for turning a voltage and current, turning on and turning off of a voltage and current source should be done with the certain steps. Turning off of independent sources. In case of voltage source, short circuit. In case of current source, open circuit it. Then we need to find out the voltages and currents according to the requirement. Fine. Now one more thing we need to keep in mind is that this superposition theorem is applicable only for linear circuits. Applicable only for linear circuits. Now what is the meaning of linear circuit? Linear circuit is a one in case if I am changing any input value, the output value should be varied linearly according to the input. Those kind of circuits can be called as linear circuits. Now before proceeding to the superposition theorem problem solving, we need to know certain steps for solving of the circuit using the superposition theorem. What are those steps? Step 1, only one independent source to be considered at a time. Should be considered, and rest all of the sources are to be turned off. The turning off of the independent sources, as we said earlier, voltage source should be short circuited, and in case of current source should be open circuited. Next, step 2, we need to follow the step 1 for all independent sources. Following of step 1 to all independent sources. Okay, third one, we need to do the algebraic sum. algebraic sum to find out the required value. Now we will proceed for superposition theorem problems. For problem solving using superposition theorem, we will consider a circuit, and in this circuit we need to find out the value of I0 which is flowing through 5 ohm resistor. So we need to find out value of I0. In this circuit, if you are seeing one current source is available, one voltage source is available, these two sources are independent sources, one dependent source is also available. As in superposition theorem, the dependent sources should not be turned off in any case. And in superposition theorem, we need to consider only one independent source at a time, and another sources are to be turned it off. For turning off of a voltage source should be short circuited, and in case of current source should be open circuited. In this circuit, initially we will remove the, as a step 1, we will remove the current source. Remove current source by open circuiting the terminals. Okay, we have open circuited it. Now I need to find out the value of I0 here. So I0 is the combined effect of both the current sources. In superposition theorem, for value of I0, we need to find out in two steps. The algebraic sum of the current flowing through 5 ohm resistor when voltage source is active, and when the current source is active. So when voltage source is active, the current will be I0 dash. When current source is active, then the current flowing through 5 ohm resistor will be I0 double dash. Now what we need to do is, for finding out the value of I0, I must apply the KVL to this circuit to find out the value of I0. For application of KVL, we need to mark the loops. So first we will mark the loop. This is, say this is current I2, and say this is current, loop current is I1, and this is loop 1, this is loop 2, and this is the value of current. The current flowing through this will be I0 dash. Now in this circuit, the I0 dash is equal to I1. Whenever we are finding the value of I1, we need to apply the value of I0 dash. Now when we are applying the KVL to the loop 1, we will get, this is the loop 1. In this, the 5 ohm resistor and 1 ohm resistor is in series, so we can write 6I1, and initially it's meeting the positive terminal of dependent source, so we can write dependent value of 5I0 dash. We need to consider the 5I0 dash, and next it is reaching the positive terminal of the 4 ohm resistor, so we can write 4 into I1, and finally negative terminal of the voltage source 20. And if you see in here, the 1 ohm resistor is common for I1 and I2 loop current, so we need to consider the I2 current effect on this resistor. When we see in the direction of flow of current, it is opposite in nature when we considering the 1 ohm resistor, so we can write negative I2, which is equal to 0. Now when we seeing this equation, this is 6I1, this is 4I1, so we can write that 10I1 plus 5I0 dash, okay, minus I2, which is equal to 20. This 20 term, when we transferring to right hand side of this equation, it will become positive. Now as we know that I0 dash is equal to I1, we need to apply the value I0 dash wherever I1 is available. So 10 I0 dash. Now the problem is the I0 dash direction is in this direction, downward direction, and I1 direction is in opposite direction. So we need to apply negative I0. So negative 10 I0 dash plus 5 I0 dash minus I2 is equal to 20. Now when we simplifying further this equation, we will get negative 5 I0 dash minus I2 is equal to 20. On further simplification, when we removing the negative signs to the left hand side of this equation, so the equation will become 5 I0 dash plus I2 minus 20, which is equal to minus 20. Say this is equation number 1. Next we need to apply the KVL to loop 2. For applying the KVL to loop 2, in this 1 ohm resistor, 3 ohm resistor, 2 ohm resistor are connected in series. So we can directly write that 6 1 plus 3 4 plus 2 6 I2, and the arrow initially finally meets the negative terminal of the dependent source. So we can write 5 I0 dash, and the 1 ohm resistor is having the effect of current I1 also. The current direction is opposite to the I2, so we can write the negative I1, which is equal to 0. Now as we know that I1, wherever I am finding the I1, I need to apply minus I0. We will apply here also. 6 I2 minus 5 I0 dash, minus of minus I0 will become plus I0 dash, which is equal to 0. On further simplification, we will get 6 I2 minus 4 I0 dash is equal to 0. Say this is equation number 2. Now I want the value of I0 dash. For that I must do the simplification. How can I do the simplification? I need to solve these two equations. When we seeing this, the common is I2. For elimination of I2, I can multiply the equation 1 with the value of 6 on both sides of this equation. So the equation 1 will become 30 I0 dash plus 6 I2 is equal to minus 120. The equation 2 we can write as it is. So when we writing this, minus 4 I0 dash plus 6 I2, which is equal to 0. When we subtracting this, the terms will be get changed, and this 6 I2 minus plus 6 I2 minus 6 I2 will get cancelled, and here we can find out that 34 I0 dash is equal to minus 120. On simplification, we can write I0 dash is equal to minus 60 by 17. So we have found out the value of I0 dash, that is when voltage source is active. When voltage source, that is 20 volt, is active. In next step, we will turn off the voltage source and we will turn on the current source. We will consider the same circuit. Okay, now we will apply the same steps to the turning off of the voltage source. So for turning off of the voltage source, we need to short circuit it. Okay, and the current source must be in active position, and we need to mark the loops. So to marking the loops to find out the value of I0. Now in this circuit we are finding the value of current flowing through 5 ohm resistor with the effect of 4 amp current source. So we can write it here. The current source will be I0 double dash. Okay, and we will mark the loops. The loop, first loop we can mark as it is. This is I3 and this is I4 and this is I5. Next we need to mark the loops. Say this is loop 3, loop 4, loop 5. This is the continuation of the numbers from the previous circuit. In this we have short circuited the voltage source. Now we will start to apply the KVL to loop 3. In this circuit we know that before proceeding to loop 3 KVL equation, we know that I5 is equal to 4 amps. We should keep in mind this value, okay, because it is the direct value, so we can keep in mind for simplification purpose of the forthcoming equations. Now KVL to, when we are applying KVL to loop 3, we know that the 1 ohm resistor, 5 ohm resistor are connected in series. Okay, so I can write 6I3. Okay, fine. Second, the effect of 1 ohm I4 on 1 ohm resistor is both the currents are in same direction, so we can write plus I4, and the effect of I5 on 5 ohm will be, this is I0 double dash, is the amount of current which is flowing through the 5 ohm resistor, but the I5 is having the effect on the 5 ohm resistor, so I can write plus the current direction of I3 and I5 is same, so I can write plus 5 into I5 plus 4 into I3 minus the dependent voltage source value 5 into I0, which is I0 double dash. We need to apply here I0 double dash, which is equal to 0. Now if we are considering this node, the current I0 double dash is coming and current leaving is I3 and current leaving in this direction is I5. So I can write I0 double dash is equal to I3 plus I5. In case of, if I want to know the value of I3, I can just do the subtraction of minus I5 from I0 double dash will give me the value of I3. So this we need to be considered, and we will apply this value in the forthcoming equations. Now this is the value. We can see that here 6I3 available and here 4I3 is available. So on simplification this will become 10I3, okay, plus I4 we have written as it is, plus 5I5 minus 5 into I0 double dash. As we know that I5 is 4 amps, we need to apply it here is 20. 5 into 4 will be 20 plus, minus 5 into I0 double dash, which is equal to 0. Now here we will apply the value of I3. So when we applying the value of I3, 10 into I0 double dash minus I5 plus I4 minus 5 into I0 double dash is equal to minus 20. Now when we simplifying the further, the 10 I0 double dash minus 5 I0 double dash, so the equation we can write, in equation we can write 5 I0 double dash positive and I5 is negative, so 10 into 4 will be minus 40. 10 into 4 will become 40 and negative sign is available, so negative 40 plus I4 which is equal to negative 20. When we transferring this equation to the right hand side of when we transferring the negative value to the right hand side of this equation, so the equation will become 5I0 double dash plus I4 is equal to 20. Say this is equation number 3. Next we need to apply the KVL to loop 4. When we applying the KVL to loop 4, we can see here 1 ohm resistor, 3 ohm resistor and 2 ohm resistor all are connected in series. So we can write 6 into I4 and the effect of I3 on 1 ohm will be the same direction of the current I4, so we can write plus I3 and the current through the 3 ohm resistor I5 is in opposite to that of I4, so I can write 3 into my negative of 3 into I5 we have written, and finally it is meeting the negative terminal of dependent voltage source, that is 5 I0 double dash, okay, which is equal to 0. Okay, now we need to simplify this equation further. For simplification, we need to apply the value of I3 is equal to I0 double dash minus I5 here also. So 6I4 plus I0 double dash minus I5. In place of I5 we will apply here minus 3I5 minus 5I0 double dash is equal to 0. As we know here the value of I5 is 4 amps, so we will apply it here. So 6I4 and I0 double dash minus 5I0 double dash, so it will become minus 4I0 double dash minus I5 minus 3I5 will become 4I5. 4 into 4 will be 16 minus 16 which is equal to 0. On simplification we can write 2I4, when we dividing this equation divided by 2 on both sides the value will remain same, so 3I4 minus 2I0 double dash is equal to 8. Say this is equation number 4. Now we need to find out the value of I0 double dash. For that we need to simplify the equation 3 and 4, so we can find out the value of I0 double dash. For that I will multiply the value of I will multiply the value of 3 in equation number 3. So we will multiply the equation 3 with 3, so the equation will become, when we multiplying this 15I0 double dash plus 3I4 which is equal to 60. Fine. When we multiplying the equation 3 with 3, the equation will become like this, and the equation 4 we can write as it is. 3I4 will be 3I4 we will write, and negative 2I0 double dash which is equal to 8. Now we need to do, we need to subtract the equations. On subtraction the sign will change as it like this. So it will become 17 I0 double dash, and this 3 I4 will be get cancelled out, plus I3 I4 correction plus 3 I4 minus 3 I4 will be get cancelled out, and the remaining will be 60 minus 8 will become 52, and I0 double dash will become 52 by 17. Now we have find out the value. This is because of when current source in active. Fine. Now we need to do the algebraic sum. Now in this circuit we need to apply the values, that is, as we have already told, I0 is equal to I0 dash plus I0 double dash, and we have found both the values. So the values are I0 is equal to I0 dash is here, that is I0 dash is 60 point, sorry, correction, the value of I0 dash is equal to minus 60 by 17. So we will write it here. We will write it here, minus 60 by 17. And I0 double dash value we know here, we have found, that is 52 by 17. So we will write it here, plus 52 by 17. So the result will be 17, and over the numerator term will be negative. So when we solving this, negative 0.4705, this is I0. Now the current direction which is given in the diagram is downwards, but as per our calculation, the current direction, that is I0, is opposite to that of the direction which is shown in the diagram. The current I0, which is equal to 0.4705, will flow in upward direction, not in the downward direction. In case of, if I want to write here, I0 is equal to negative 4.4705, I can write. So this is how we can apply the superposition theorem to solving the circuit. In this superposition theorem, we are using only the nodal and mesh analysis. Now we will see a disadvantage to this theorem. The disadvantage is when n number of independent sources is available, we need to repeat the steps to all independent sources. So it is lengthy process, and it needs and we can say that it is consuming more time. It requires more time to solve the circuit. This is the drawback of this superposition theorem. I hope all the viewers might have been understood so what is superposition theorem and how can we apply into the circuit. So I have took this circuit because it has all three different sources are available, that is voltage source, current source, and dependent source is also available. If you have any doubt, kindly write it on the comment box. If you like this video, kindly hit the like button on this below this video. If you have not subscribed my channel, kindly subscribe it. Thank you so much.